Okay, let me give you one example which is concerned with undamped free vibration. Okay, so since it's undamped free vibration, and we're going to use this differential equation. Okay, m u double prime plus k u equals 0. Okay, so first of all, in the problem they said like the mass is 100 gram, and which is given, so that is m. Right? And then, like, with this weight, with this mass, like your spring is stretched by 5 centimeters, right? And with this one, we can easily find the spring constant K, right? Here we go. By the Hooke's law. What is that? So it is mg must be equal to ku, which is displacement, right? So look at that. So m is 100 gram, and well, for this case, like they are using centimeter instead of meter, right? So basically, like your gravity is 9.8 meter per second. Then for this case, we can say 980 centimeter per second square. Okay, I'm sorry, like not second, but second square. And we need to find constant K, and it is stretching by 5 centimeter, right? Just simply divide by 5 on both sides, we can find, okay? Your constant K is 19,600 gram per second square. Okay, this is my constant K. And with like given M and K, we can update my differential equation, okay? My differential equation will be 100 u double prime plus 19600 u equals 0. Okay, now we are ready. Now we're gonna talk about a detail of this one, okay? Here we go. So like since this is like second order, a homogeneous second order linear differential equation with constant coefficient, we can solve this one by the characteristic equation, okay? Before then, let me divide by 100 on both sides. Might much simpler and easier. And u double prime plus 196 u equals 0. Then the characteristic equation, which is r squared plus 196 equals 0, and minus 196 on both sides. Then your r squared is minus 196. And we're going to take the square root on both sides, and definitely plus and minus sign in there. And my r is the 14i. I is equal to square root of -1, right? That's it. So now, since it's imaginary number, I'm sorry, plus and minus sign. Since it's imaginary number, we can easily find the general solution set, right? Which is A cosine 14t plus B sine 14t. Okay. Well, like A and B's are the arbitrary number, right? But like in this problem, we have some initial conditions to verify A and B, right? Let me come back to the problem, okay? Look at that. So, well, the motion starts from the equilibrium position, which means there's no displacement at the beginning, right? So it is u0 equal to 0. And then the downward velocity is given, right? As you talked about it, as long as your spring is stretching out, it is positive direction, okay? So downward velocity is given, like, we can consider as positive value, right? Centimeter per second. The unit is fine, okay? We can use these two initial conditions for, like, to verify A and B, right? Here we go. Let me write here, okay? Right? Here we go. Then look at that. Since u0 equals 0, A times cosine 0 plus B times sine 0 must be equal to 0. As you know, sine 0 equal to 0, then we can easily say your A must be equal to 0. Okay. Then with this one, let me update my solution set, okay, solution curve. Okay. ut is equal to just b sine 14t. So for this case, since it's not a combination of sine and cosine, so we don't have to worry about how we can combine, how to combine your sine and cosine function as one cosine, right? We can use this, okay? Then we use another initialization, right? It is 14b cosine 14t, right? Then and since your u prime 0 equal 10, 14b times cosine 0 must be equal to 10. And as you know, cosine 0 equal to 1. Then we can say your b is 10 over 14, which is 5 over 7. Okay? So now, with this information, we can update again. There we go. My solution curve is equal to 5 over 7 sine 14t. Okay? So now let's talk about the detail of this function, okay? Here we go. The frequency. Is omega, which is 14. That's it, right? Then what is the period? It is 2 pi over omega, right? So we can say pi over 7, that is period, okay? And amplitude is the coefficient of your sine function, which is 5 over 7, and the phase, we normally notate delta is pi over 2, okay? How can you get this one? Because tangent delta must be equal to b over a, and your b is 5 over 7 over 0, okay? But look, let me come back. So basically, this motion start from stretching out, which means your y value is positive, and then your t equals 0, right? So, which means your delta, angle delta must be positive y direction, which is pi over 2. That's why we can say this is infinite. That's why your delta is pi over 2, the positive direction, okay? And also in this problem, they ask you to find the, when it will be reached to the equilibrium position again, right? At the first time, right? So here you go. How can I do it? Which means your u equals 0, okay? We just simply set your u equals 0. Sine 14t must be equal to 0. Then we can easily find your sine 14t must be equal to, it is 0, but 0 is starting point. So next one is pi, right? So here we can say when your time reaches to pi over 14 seconds, then it will be come back to the your equilibrium position, okay? That's it.